Okay, this lesson we're going to be looking at those two other remaining graphs, the quadratic or the parabola and that exponential function. And we're going to be doing kind of the same thing. We're going to be able to graph it and then also write the equations and then domain and range. All right, so let's start. So here's our direction. So you want to graph it. So graph and then domain and range. Okay, so number one. Let's start with a parabola. So we're going to graph it. Y is equal to x squared minus 1. X squared minus 1. Well, first of all, how do we know that this is a quadratic or a parabola? Because of the squared. Okay, good. Just want to make sure we got that. All right, so let's go ahead and sketch it. Well, just like the lines and the V's, the absolute values, we can shift the starting point. Normal starting points, right where my pencil tip starts, right at the origin. How does this thing shift? How does the vertex, where does the vertex move? How does it shift? It goes right one, down. Okay, well, okay, so here's our, quote, parentheses being squared. So it's like x minus 0. So this doesn't go left and right, but it does go down 1. Okay, so it doesn't go left and right, it goes down 1. Bingo. There's our parabola, or our vertex. There's our vertex. And then we know it's a parabola that does this open up or down? Because
it's not negative.
It's not negative, so it's a positive 1, right? So if we had to just do a quick sketch, we just know it looks like this. That's what it looks like. But on the test and quiz, we just need a little bit more accurate. We need another point or two. So we shift it. There it is. Let's just go ahead and pick a point to plug in. So what do you want to plug in for x? Let's pick 1. So if I pick 1 for x, what are our operations? Got to square it. So 1 squared is 1, minus 1, 0. And we can all plot a point. So let's go ahead and plot 1, comma 0. There it is. Knowing that this is our vertex and it opens up and it goes through that point, I know it opens up like this and it's symmetrical on the other side. There's your graph. There's your graph. Okay. If on the test or quiz I require 2 extra points, let's go ahead and pick another point. I know I could pick -1, but let's go ahead and pick 2. So if I pick 2 for x, let's substitute 2 in for x. 2 squared is 4, minus 1 is 3, and again we can all plot. So 2 comma 3, 2 comma 1, 2, 3, but that would have been right there, and there you go. So we can pick 1,000,000 points if we want to, but we can pick 100. All right, domain and range. Okay, domain and range. I want to call on you guys for domain and range. We should be a little bit better at this. So domain, Josiah?
All real numbers.
All real numbers. Okay, and if I wanted to write that in interval notation, that would be from?
Negative, infinity,
to positive infinity. There you go. Excellent. Okay, and then Presley, the range of heights. So what's our range of heights? What's our range for this graph? To infinity. There you go. So the lowest is -1, the highest is infinity. Okay, and then Presley, is that a square bracket or curved? Square bracket, because there is a y equals -1. Okay, all the way up to infinity, and there we go. Nice. Nice. Okay, let's look at another one. Number 2. Y is equal to -1/2 parentheses x plus 2 squared minus 3. We'll do the same thing. We'll sketch it, domain and range. We should be getting better at this. All right, let's draw a little xy axis. Okay, so Trinity. So Trinity. Normally the parabola or parent graph starts right there at 0, 0. But this thing shifted. So how does it shift? It goes down 3 for sure. There we go. It goes down 3. What else, though, Trinity? What does this tell us? It's a left or right. There it goes. Goes to the left 2. Right? Because think opposite in there. Or what makes that 0? Negative 2 makes that 0. So left 2, down 3. There we go. There's our new vertex. The vertex shifted. Okay. And does it open up or down? Opens down because it's negative. So we could pretty much just do this, but we need to, if this is a test or quiz, we need to show an extra 1 or 2 points. So let's just make a little t-chart, x and y. And then let's pick some values there. So what do you want to plug in for x? Okay, 1. We could definitely pick 1. Just looking ahead here, it's going to give us a little decimal. Won't it? 1 plus 2 is 3 squared is 9 divided by 2, 4.5. I mean, we could do it, but let's just avoid that. I mean, there's no problem with it, but I just like to avoid decimals if I can, or fractions. Let's pick,
2.
okay, 2. So if we pick 2, that's good. So 2 plus 2, order of operations. Do it in the parentheses. 2 plus 2 is 4. 4 squared is 16. Half of 16 is 8, but it's negative times positive, so it's negative 8. Okay, what is negative 8 minus 3? Negative 11. Okay, we could do some arithmetic. There we go. So we'll plot that in a second. Maybe, maybe not. Let's pick another number. Let me help you out. Let's pick 0. Let's pick 0. 0 substitute in for x. So 0 plus 2. So we have 2 squared is 4 times negative a half. Negative 2. What's negative 2 minus 3? Negative 5. 0, negative 5. Okay, there you go. So let's go ahead and plot 0, negative 5. So 0, negative 1, 2, 3, 4, 5. There you go. 0, negative 5. I know this is my vertex that shifted. 2 to the left, down 3. And I know it opens down. I know my graph looks like this. It's symmetrical on the other side. There's my parabola. There's my parabola. If we wanted to plot 2 comma negative 11, it'd be down there. Okay. Domain and range should be easy now. Domain and range. Okay. So let's, domain is all real numbers, negative infinity to infinity. And Axel is going to tell us our range of heights. Axel?
Range is -3.
Okay.
With a bracket.
With a bracket, yes.
To -50. Or infinity. No. Yeah, negative.
Negative infinity. Okay, so -3 to negative infinity like that.
No, switch it.
There we go, because we want the smaller number. Negative infinity is a small number. Okay, small number on the left. Good. So negative infinity to -3, we include that. There it is. From down there all the way to up there. Perfect. Good, good. All right, so let's look at exponential. So kind of easier now that we know shifts, isn't it? Okay. All right, so let's look at, so number 3. Y is equal to 3 to the power of x minus 2 plus 1. Okay. So we're going to sketch it, domain and range. All right, so this, so we're going to sketch it, domain and range. These are pretty easy, but we've got to remember where it starts. All the other 3, the line, the paragraphs at the origin, 0, 0. The parabola is 0, 0. The v is 0, 0. That's where it starts. Well, what's different about the exponential? Where does it start? 0, 1. Okay. I'm not going to put a dot there, but there's my little slash mark for 0, 1. It's okay. So I bet, without me even saying anything, we could all do this. But I'm going to say something. Okay. So this shifts. The starting point shifts right where my pencil is. Well, what do you think? How does it go? Shifts to the right 2, and up 1. Okay, so this is kind of like our parenthesis. You can even put it there if you wanted to. So it goes to the right 2, up 1. From the start, there's our start, not there. So it goes to the right 1, 2, and then up 1. There it is. Okay, so it goes to the right 2, up 1. Okay, so that's our new start. Okay, now what I want you to do is I want you to draw the horizontal asymptote. And it's always a space of 1. And then just draw a dotted line just like that. Okay, so there's our new start. Shifted 2 to the right, up 1. It's always a space of 1. And then we draw a dotted line. Okay, perfect. That's easy. And in fact, if we just had to do a quick sketch of what it looks like, we know it's an exponential. It looks like this, doesn't it? So, but what we just need a little more accuracy on a test, so what should we do? Let's pick a point and plot it. So let me just do this as a little t-chart. All right, so a point that I would say is easy to plug in is right there, one more this way. So 3. X is 3. X is 3. So this should be, well, let's plug in 3. What's 3 minus 2?
1.
1. What's 3 to the first? 3. What's 3 plus 1? 4. Okay, there we go. So we plot that and we're good to go. So 3, comma, 1, 2, 3, 4. There it is. And now we can sketch it. Okay, so it's going to go towards our horizontal and go through our points, shoot right up there. It's an exponential growth. There we go. Nice and easy. We shift the starting point, we pick another point, and we got it. Okay, and next, so let's do domain and range. This should be, again, review. All right, so domain of x values. What's our domain? All real numbers, negative infinity to infinity. Okay. Range of heights. What's our range of heights? What's the lowest this thing gets, or close to? 1. That's our horizontal asymptote, right? It gets close to 1 but doesn't touch it, so it goes from 1, it's got to be curved because we don't have a height of 1, all the way up to positive infinity. Infinity and beyond. Okay. Number 4. Okay. Curved on the 1, yes. Yes. Because we don't touch 1. Okay, y is equal to 2 to the x minus 4. You're on your own. I want you to graph this. And domain and range. Okay, so you do the shift of the starting point. Do the shift of the starting point. And then graph. So just remember the starting point is at 0, 1. Left and right shift, and your up and down shift. Pick one other point. Know what the shape looks like. I do want you to put the horizontal asymptote in there as well. Put the horizontal asymptote in there. Okay, I know you're still working on these, but just for sake of time, I need to do the writing equation thing. Sunny? Okay, so how did this shift in words? How's it shift? As far as a slope,
Yeah.
or well, we don't have a slope. It's not a line or a V.
So would it just go right 4?
Um,
Or would it just go to 0, -4?
okay, it would just go down 4, like this. There's nothing really in the parentheses. All right, it's just nothing left and right. Okay, and then down 4. So, but Sonny, down 4 from where? Where's our normal start? Right here? If this is an exponential, 0, 1. Yeah. Okay, so from here we go down 4.
So it's 0, -3.
Good. 1, 2, 3, 4. That's our new start. That's our new start. Okay? So normally it was right there, but then it goes down 4. That's all it did. Shifted down 4. Where do we put the horizontal asymptote? One space of 1, right there. Okay, good. And then we know the graph looks like this, but let's just pick a point. How about we pick a nice easy one? What should we pick? X is 1. 2 is good too. Let's just pick X as 1. 2 to the first is 2. What's 2 minus 4? -2. So just plot 1, -2, and we're good. 1, -2, got it. 1, -2. And we know what the graph looks like. Goes towards the horizontal. Goes up, shoots up through there, and there's our exponential function. Okay. Domain is -infinity to infinity. Range of heights. Where's our range? What's the lowest this thing gets? Negative, wherever this horizontal asymptote is. 1, 2, 3. So -4, curved bracket, is the lowest, all the way up to positive infinity. Okay. So far, so good? Okay. All right, so we got to do a couple more here in 9 minutes. Writing the equations. So let me just start another piece of paper here. So writing the equation of a parabola and also an exponential. So write the equation. That's number 5, I think we're on. All right, so go ahead and draw this parabola. So 1, 2, -1, plot the vertex, 2, -1. And then plot 1, 2, 3, 4, comma 5. 1, 2, 3, 4, 5. 5, there's 4. 4, comma 5. Put a dot there. And then draw your parabola. Looks like this. And it looks like that. Okay, that's 2, that's -1. Okay. So let's go ahead and write this equation. Let's see. Just as easy, but we're going to have to find that A value, kind of that stretch number. Right? It's not a slope. Okay, put that number in front of that x squared. But go ahead and write our general equation. Y equals A, parentheses. You've seen this last year in Math 2, Math 1 as well. X minus H squared plus K. Okay, it'll be in this form. Okay, and so let's start writing. We'll probably get 80% of this function right here, this equation. So it shifted from the origin to parabola. So 0, 0. It shifted 2 to the and down 1. Okay, so let's start writing this. Y equals A. We don't know that stretch number. Y equals A. So when 2 to the right, we should be able to write this. X minus 2 squared, don't forget squared, and then went down 1. Minus 1. Okay, we can all do that if we know the shifts, right? Good. All we have to do now is find the A. Well, we did that last night on the homework. How do we find the A? Okay, it's kind of slope, but it's not a line. We did it a different way. What did we do? We plugged in a point. Don't plug in the vertex. Plug in another number. Okay, so we plug in a point. So the point is at 4, comma 5. That's your x, that's your y. We plug it in, do a little arithmetic, that gives us our a. Okay, still with me here? I know I'm going to go kind of fast on these last two. I was running out of time here. Okay, so let's plug it in. So y is 5. So 5 is equal to a times x, which is 4, minus 2 squared minus 1. Let's plug it in. Now let's go ahead and PEMDAS. Please excuse my dear Aunt Susie. Just kidding. Okay, so 5 is equal to, let's go a, and this is 4 minus 2, so it's 2 squared minus 1. It's not skipping any steps there. This is not 3, by the way. So 5 is equal to, this is a, this is 2 squared is 4, and then minus 1. You can call that 4a if you want. Why can't that go 4 minus 1? Yeah, this, well, we did the exponent, but this is multiplication. It's kind of attached there. We got to add the 1 over there. This is being multiplied there. We got to add the 1 first. So add the 1, add the 1. You can't go 4 minus 1. So that's 6 equals, I'll call it 4a. Divide by 4, a is equal to 6/4, which is 3 over 2, reduced. Okay, let's write the equation. Sorry, I'm going a little quick here, but here's our answer, our equation. Y equals 3/2 x minus 2 squared minus 1. Circle that. There we go. Okay. So just re-looking at it, it went 2 to the right, down 1, and we found that stretch number by plugging in a point. Okay, let me do the exponential. Okay, number 6. So draw this and we'll write the equation. So 1, 2, 3, 1, 2, 3. So plot 2, 1 and 3, 3. Okay, and graph it like this. Okay. So exponential. I'm gonna go real quick here. Okay, it normally starts there at 0, 1. It shifted, here's my new start. This is my new start. Not this one, but this is my new start. It shifted 2 to the right. Did it go up and down? No. So y equals b, we don't know the base yet, b to the 2 to the right. So x minus 2, and then plus 0. We don't have to worry about that. Let's get our b. Let's do the counting way. What's this space? From this to this. 2. Then we do plus 1, which is 3. Then what's this space horizontally? 1. So that's our base. There it is. Y equals 3, that's our b, to the x minus 2. That's our equation. Let's do one last one. Sorry. This is going to be a little off. Okay, so do this. Go ahead and just graph this like this. Put this at 2, 7. And this at 5, 33. Okay, 2, 7, 5, 33. All right, so y is equal to b. Let's look at the shift. Okay, starts at 1, 0, 1. So to get to this point, I have to go over 2. So it's x minus 2. Then I got to go up 6. So plus 6. 30 seconds. And I got to hand out the worksheet. Sorry. This space is 26. 26 plus 1 is 27. This space is 3, so I take the cube root. Cube root of 27 is 3. So it's y equals 3 to the x minus 2 plus 6. At least we got it all on our notes there. Before you leave, let me hand out the worksheet. Got it? Good.